I'm Shamidu, and today we are dividing deep into a powerful hybrid data structure called the stick. This structure is often overlooked in traditional computer science classes, but it has real world value, uh, especially when performance and flexibility matter. By the end of this video, you will not only understand what a stick is but also how to implement one in Java with circular array and where it's used in real application. So what is a stick? The name stick comes from combining two data structures, stack and queue. Stack, which use the last in first out method LIFO. Queue, which uses first in first out FIFO. Stack supports three cooperations: push, enqueue, and pop. Push add to the front like a stack, and enqueue add to the back like a queue. Pop remove the front again like a stack. This combination gives you versatility. You can choose which end to add to and remove from. Uh, LIFO versus FIFO. Let me explain these two concepts briefly. LIFO stands for last in, last out. Imagine stacking books. The last one you placed on the top is the first you remove, and FIFO stands for first in, first out. Think for a queue at supermarket. The first person in line is served first. So in a stick, push and pop follow LIFO, last in, first out, and NQ follows FIFO, first in, first out. This makes it perfect for applications that need both behaviors. Why use a stick? Why would you use a stick instead of just a stack or a queue? It gives you more flexibility. You can insert and remove from both ends. It's useful in undo-redo system, task scheduling, and real-time command processing and text editors. And the best part, operation like push, enqueue, and pop all run in a constant time known as O1 or fast O1. This means it doesn't matter if you have 10 items or 10,000, it takes some same amount of time to this operation. Internal design, circular array. Now let's talk about how we implement the stick in Java. We will use a circular array to make it fast and efficient. We keep track of front, rear size. Front, the index of the first element, and rear, the index after the last element, and size, how many elements are currently stored. Why a circular array? Imagine an array of a size 5. If we fill it up and remove some from the front, we don't want to shift everything forward. Instead, we wrap around like a clock to reuse space. That's the beauty of a circular buffer. Push. Let's start with the push method. Here's how it's written. First, we check if the array is full using size equal capacity. If so, we resize the array to double the size, and next we update the front pointer. If it's at index 0, we need to wrap around to the last index using modular arithmetic. Front minus 1 plus capacity. Then we store the new item at the new front, and finally we increment the size. So this operation adds new elements to the front like stack, but uses a circular structure to avoid shifting. NQ. Now let's look at the NQ method, which adds to the rear. Again, we resize if needed. Then we place the items at the current rear index, move the rear forward. If it goes beyond the array size, it wraps around, increase the size counter. This is just like a queues and queue, constant time, no shifting needed. Uh, Pop. The third operation is pop, which removes from the front. We check if the structure is empty. If so, we throw an expression. Store the front element in a variable. Move the front pointer forward. Decrease size. Return the remove element. This is similar to stacks pop, but optimized with the circular array. Resize. When the array is full, we resize it like this. We double the capacity, copy all elements in order, starting from the front handling wraparound, reset front to 0 and rear to size. This lets us grow dynamically while maintaining order and performance. Using example. Now let's walk through a real example. Each operation affects the structure. Push adds to the front, NQ adds to the rear, pop removes the front, and everything runs constant time O1. And output. First we push 10 and then 20. Stack style. Last in, first out. Then we NQ 30 and 40. Q style, first in, first out. When we pop, we remove 20, which was at the front. A great example of how stick combines both behavior seamlessly. Real world use case. Let's talk about some real world application of the stick. On the radar system, push recent action onto the front. NQ radar operation in the back. Task scheduling. High priority tasks push to the front. Normal tasks NQ'd at the back. Web browser or editors. Navigate history of commands forward and backward. Simulation system. Entity types that must be updated in both stack and queue orders. This structure is not just academic, it's a practical. Let's recap what we learned. Arraysteque is a hybrid of stack and queue. It supports push, NQ and pop, giving you full control. It uses a circular array for efficient memory use. All operations run O1 time fast and fast. It's great for Android scheduling, task queues and more. Thank you so much for watching.